Hello Internet, welcome to another video on 8051 microcontroller. In this video I'll be talking about addressing modes of 8051. In order to program 8051 in an efficient manner, you need to have a very thorough understanding of all the addressing modes of 8051 because these are the ones which will determine the possibilities, the immense possibilities that lies within 8051 to perform specific tasks. So let us begin with the addressing modes of 8051. This is going to be a two-part series, and in this first tutorial I'm going to be talking about the addressing modes for the internal RAM only. So everything that is going to be moved to and fro will be within the internal RAM. So that being said, let's move on to the structure of RAM. We've already discussed the structure of RAM in the previous tutorial on 8051. We know that the RAM size is 128 bytes. It starts from 00H and goes up to 7FH, and it is further divided into 4 register banks. Each register bank has 8 registers. It has bit addressable area of 16 bytes and a general purpose register area of 80 bytes, and this one extends up to 1FH. It starts from 20H and goes up to 2FH, and this one starts from 30H and goes up to 7FH. So it is very important to understand that we are talking about registers in this particular area, and some of the registers which are labeled as SFRs. So there are 21 SFRs, and all of them have an address. For example, accumulator has an address of E0H. Similarly, port 0 has an address of 80H, and so on. So a key point here is that we can use any of the addresses from 00H to 7FH in the addressing modes that we are going to discuss today, and we can use 21 more addresses which are specific to SFRs. And if you do not remember the addresses of all the SFRs by heart, then I highly recommend you to watch my previous video on the structure of memory of 8051 to get a hold of all these addresses. Alright, now let us begin with the first addressing mode, which is immediate addressing mode. Now this mode is the simplest mode of addressing, and this implies moving a specific number into a specific register. For example, let us randomly take this register and let us say this register is 30H, and we want to move a number into this register, and that number could be a maximum of 8-bit number. We know every register is an 8-bit register, so we can move a maximum of FF number. We can put all ones in all these 8 bits, that is it, and that amounts to moving FFH into this register. So how can we move a specific number into a specific register? For that we'll use immediate addressing mode, and any immediate data, any immediate number that you would want to move is specified by the symbol hash. And this is very, very important. The mnemonic for immediate data is the pound sign or the hash sign. And occasionally in the rush to meet a deadline we might forget to use the hash for immediate data, and that will result in very, very big mistake. So let us say if we want to move into accumulator some number, the content of accumulator would become all ones. So it will become all one, which is FFH. Similarly, if we want to move into any register in a register bank some number, we'll make sure that we put a hash next to it. Now what will happen here is R0 of the selected register bank will be entered with the number 3AH, and 3 is 0011, A is 1010. So the contents of R0 register will become 0011 1010, which is 3AH. So immediate addressing mode is specified by the hash sign, and any immediate data that you would want to move is written next to the hash sign. Now there is very, very important thing that we need to take care of while moving immediate data, is that whenever the number that we want to move begins with an alphabet, for example in this case F, or let us say we want to take this scenario where we want to move into R1 register some number which is starting with an alphabet, for example BCH. We'll need to make sure that any number, 8-bit number, is preceded by a 0, otherwise it will consider it as a label. So this is very, very important part, that if a number begins with an alphabet it should be preceded by a 0, but if the number begins with a number then it is okay to specify it as it is. So register R2 will get a number 21H, which is of course 0010 and 0001. So these will become the contents of register R2. So this was the easiest addressing mode and the most used one, because any program would begin with moving a specific number into a specific register. For example, counters, if we want to start a counter, we'll put a specific number into the counter, and so on and so forth. Very, very important. So hash and a small little care about putting a 0 next to any number that starts with an alphabet. The second addressing mode is register addressing mode. Now this addressing mode is very simple. Register addressing mode copies the contents of one register into the other register, and it includes the involvement of A in the registers. For example, if you want to move the contents of R0 into register A, we'll use this instruction where the register this is the source and this is the destination register. The register before comma is the destination register and the register after comma is the source register. Now I'd like to mention the most important point that we all miss in register addressing mode is that register to register moves, they occur between register A and set of registers R0 to R7. So any movement between the registers will occur between A and R0 to R7. So this is the limitation on register addressing mode. They are only applicable to, or they occur between registers A and the registers of the selected register bank. Whatever register bank is selected, all its participant registers ranging from R0 to R7, they can move their data to and fro to A. So that was very important point. Otherwise, this is the most easiest one to understand. Now we move on to the third addressing mode, which is direct addressing mode. Now in direct addressing mode, all the 128 bytes of internal RAM, so we could say 128 bytes of RAM, so they range from 00H to 7FH, and the SFRs in their hex addresses. So we'll be talking about the actual hexadecimal addresses of SFR. So here is where the remembrance of hexadecimal addresses of SFRs is of paramount importance. So again, I'll give some examples here. For example, move A, comma, some address. For example, some valid address from this range 3FH. Now please understand, this is not going to copy the number 3FH because we haven't put a hash next to it. So this is going to copy the contents of register 3F into accumulator. Register 3F will be somewhere here. So whatever the contents of this register, it will go into the accumulator. And similarly you could use move R0 and for example E0H. Again we need to put a 0 next to any register that starts with an alphabet. So this is going to copy the contents of accumulator into the R0 register of the selected register bank. And another example is move into, let us say, some random register 7FH, some number. This is also possible. And so what will happen is the last register of the RAM would now contain the number 00111010. So this can be thought of as an example of direct as well as immediate addressing, because we're using immediate data as the source and direct address as the destination. So but be careful about putting a 0. For example, this is another example where we are moving 77, the contents of 77H. Please understand, contents of 77H into the special function register A8H. Now this 0 makes sure that it is not being considered as a label. And